morning, everyone. My name is Dr. Nagaraju, working as Assistant Professor in the Department of CSE and ML in Institute of Aeronautical Engineering, Hyderabad. So today we are here to understand the concept of implementation issues. It is a continuation session related to the monotonic and non-monotonic reasonings. So if you have not come across with that video, I am sincerely suggesting you to go through that video and try to understand what do you mean by monotonic reasoning and what do you mean by non-monotonic reasoning, and then you can watch this particular video. But because we are going to see the continuations, and especially we are going to talk about non-monotonic reasoning systems, and we are also going to see what are the implementation issues that arises while implementing these kind of systems. At the same time, we are going to see the logical systems and also the implementation issues that present in maintaining these logical systems. And at the end, we will try to see a concept called as augmenting a problem solver with an example. So in module 1, in chapter 2, we have come across with a ABC murder story. So that ABC murder story, we are going to take it as an example to understand how this augmenting a problem solver can be done. So let us move into the concepts directly. Let us try to understand what do you mean by monotonic reasonings. So in simple and short, I will try to recap the definitions of monotonic reasoning systems and non-monotonic reasoning systems. So in monotonic reasoning systems, what happens whenever a particular conclusion is given, or we can say whenever a particular conclusion is proven to be true, then even though if you are adding new knowledge to the existing knowledge base, then it is not going to be changed. Means in the earlier case, in the monotonic reasonings, for example, a certain conclusion has given, and if that conclusion is S, and even if you are adding new knowledge to the knowledge base, that S is going to be like that. Means there will be no change in the conclusion. But when it comes to non-monotonic reasoning systems, the conclusion is going to change regularly. Means at one particular case, the conclusion may be proven to be true, or we can say the conclusion is true or S. But when we are adding new knowledge to the knowledge base, then that this S may become no. So we will try to see how that conclusions are going to differ in the non-monotonic reasoning systems. And we can say especially in these particular reasoning systems, the conclusions may be invalidated. So that's why I'm telling initially what happens. For example, if a particular conclusion, if any of the particular conclusion, if you have proven to be true in one particular case. So what happens whenever you are adding new knowledge to the knowledge base, what happens, this conclusion means whatever the conclusion we have proven to be true, we have proved to be true, it is going to become false. There is a possibility. Means what happens, the conclusions are going to be invalidated. Why? Because in the earlier case, we have proved that this particular conclusion is true. But what happened when we kept adding the new knowledge, it became false. So that's why we say that in non-monotonic reasoning systems, the conclusions are going to be invalidated. So in what case? Means whenever you are adding new knowledge to the knowledge base. That's why we say that non-monotonic reasoning systems are going to handle the problem of uncertainty. Uncertainty in the sense where we are not going to be where we are not going to see the same thing every time. One time it may be true, and one time it may be false, and conclusions are going to change regularly. So when it comes to the logic, we can also say that logic is also a non-monotonic reasoning system. Why? Because in this particular case also, some conclusions are going to be invalidated. Means not only in the non-monotonic reasoning systems, but also what happens even in representing the knowledge in terms of logic also, the conclusions are going to be invalidated when we are adding the new knowledge to the existing knowledge base. So we know that the representation of logic will be done by taking the knowledge from the knowledge base itself. So the knowledge which is providing by the non-monotonic reasoning systems itself. That's why even in non-monotonic reasoning systems and even in logical systems also, the conclusions are going to be invalidated when we are adding new knowledge to the existing knowledge base. So that's why we say that non-monotonic reasoning systems deal with the incomplete and uncertain models. Incomplete and uncertain. Why it is incomplete means it is not giving any conclusion to us. Even if the conclusion is given, that conclusion is going to be changed regularly. That's why we say that it is an incomplete. And why we say it as uncertain means it will not remain same. It's keep on changing. Okay, for example, if you take human perspective for various things in daily life, The opinions of the humans, sometimes it may be a positive opinion to a particular thing, and sometimes what happens, it is going to be a negative one. Means the opinions of the people, how they are changing regularly in their lifestyle. In the similar fashion, even in non-monotonic reasoning systems also, the conclusions are going to change. So we need to see how that changing generally will happen, and how it is going to reflect on solving the real-time problems that we need to see now. So coming to the logical systems, in these logical systems are going to involve with the representation of the knowledge. So these representation of the knowledge for what purpose? For the agent's perspective. That's why we say that the knowledge representation is for the agent's world. In the sense, we can say that it is in the form of a program. It is in the form of a program. Means the knowledge from the knowledge base will be taken, and it will be converted in the form of a logic. Why? Because until and unless you represent it in the form of a logic, it will not be understood by the AI agents. Okay, that's why what we do is the general English representation of knowledge we will convert into the programmatical way. That's why we say that it is a logic representation. Okay, so logical AI involves the representation of the knowledge which is suitable for the AI agents to get understand. And we are also going to include the goals and the current situation by sentences in logic. Okay, so it is going to talk about the goals, it is going to talk about the current situation, it is going to talk about what are the rules that we have, or what are the operators what we have that are available, and what we can apply, and how we can resolve the problem. So that kind of sentences that generally we are going to get it from the knowledge base. The same sentences we are going to represent in the form of logic, so that that statements can be understood by the AI agent, and it can learn something from it, and it can exhibit the intelligent behavior. So after learning from the logic representations of those sentences, then the AI agent is going to decide what action need to be performed. Okay, so we can say that it is a kind of learning process where we provide the knowledge in the form of logic to the AI agent. The AI agent will learn, and based upon his learning experience, he will try to understand. Means he will try to implement, or he will try to take up a action which will lead him towards the goal. Okay, so that's why we say that logical systems is also somewhat similar kind of representing non-monotonic reasoning systems only. But only the thing is, logic. Whenever we say it as a logical systems, we need to talk in perspective of the AI agents, where the AI agents is going to decide which action need to be performed at what time, and what action will lead us, or lead an AI agent to move towards the goal state. So let us come to the implementation issues. So what are the different issues that we are going to face whenever we are implementing these non-monotonic reasoning systems and logical systems? So if we talk about these logical frameworks, so we can say that just the logical frameworks towards a basis for implementing non-monotonic reasoning systems in problem-solving programs are not enough. Why? Because when it comes to real-time applications or real-time problems, those problems are too complex. So in order to solve such kind of problems, simply having a logical representation or logical framework does not make us to get the solution. So in that case, what happens? These logical systems are going to be not strong enough to solve the problems. That's why we say that there is some kind of implementation issue, some kind of weakness that we are going to see, which will not make us to get the solutions to most of the major complex problems. So what we can say that they are failed. Okay, so in what case? Generally we are saying that they are failing, or they are not suitable to solve most complex problems. So we need to understand what are the reasons, or in what particular area these systems are really getting failed. So we can say that there are 4 important problems where these systems are unable to give the answers. So we need to understand what are the implementation issues that arise in this particular 4 important problems. Why the logical systems or the non-monotonic reasoning systems fail in representing the real-time problems, and how they are making us to work with the real-time systems. So let us try to understand how it will be. So how to derive exactly those monotonic conclusions? That is very, very important. Why? Because we know that to the knowledge base regularly we are adding the new knowledge every time. So whenever we are doing such kind of things, how can we able to extract the conclusions? How can we extract the conclusions from these non-monotonic reasoning systems? Why? Because sometimes what happens, it will become some waste of time also. Why? Because the knowledge which is not suitable, or which does not suitable to the problem solving, if we are adding such kind of knowledge to the knowledge base, it will not make us to get a solution. So in that case, what happens, whatever the time that we took to solve the problem, it will become waste. So that's why, without wasting much more time, without spending much more time, how can we able to extract the conclusions from these non-monotonic systems? That answer we need to get it. Okay, so that's why we can say that this is one of the implementation issue while implementing the non-monotonic reasoning systems. Why? Because it does not exactly derive how these non-monotonic conclusions can be derived. So the other important point is how to update the knowledge incrementally as the problem solving progresses. So every time we are telling that in non-monotonic reasoning systems, we are keep on adding the knowledge to the knowledge base, but we didn't clearly mention how the updation of that knowledge base will be taken when the problem is in the solving state. So for this particular question also, the non-monotonic reasoning system failed to give the answer. The other important question is how to overcome the problem where more than one interpretation of the known fact is qualified or approved for a available inference rules. So just these kind of things generally we see in the production systems. When one or more operators are suitable to a particular situation to apply, then which one to need to be selected. So we are going to make use of the control information to select the best suitable operator, and we will apply it. In a similar fashion, whenever there are more than one fact which is suitable to that particular situation, then which one we need to select. So in that particular aspect also, the non-monotonic reasoning systems fail to give the answers. And the fourth important one is, we can say, the theories are not computationally effective. Even though if you are implementing, okay, so the results, whatever we are getting, they are not up to the mark. And even we can say that none of them is decidable. None of them is decidable means we cannot decide exactly this will be the final conclusion like that. So some statements are in some particular area, they are semi-decidable. Semi-decidable in the sense that will be in the form of the propositional forms only. And but still we can say that these non-monotonic reasonings in many of the cases, they became not effective. They are not so much effective in solving the complex problems. So what we have to do is we need to make the refinement. Means we need to do some kind of upgradations or some kind of refinement to the non-monotonic reasoning systems, so that even they are suitable to solve the problem of uncertainties. So what are the solutions for that? Of course, till now we have seen the four important problems, but now we need to see what are the solutions, means how we can overcome them. So one solution we can say that here, especially in the reasoning systems, it's better to split the entire reasoning system into two subunits. One subunit we can say it as a problem solver, and another subunit we can say that it is a true maintenance system. Okay, so what we are doing in this particular case, in order to solve the problem of the implementation issue of this non-monotonic reasoning systems, we are dividing the entire process into two subunits, where we are calling one subunit as a problem solver and another subunit as a true maintenance system. So what the problem solver will do? Problem solver is going to make use of certain kind of mechanisms, and which will be used in order to draw the conclusions. So I'm repeating the statement once again. Problem solver is going to make use of certain kind of mechanisms through which the new conclusions can be drawn. So what kind of mechanisms, that we will try to see with an example. And when it comes to the true maintenance system, we can say that it is a kind of management system also. So what is the main importance of this particular subunit? Means it has to take care, means it has to store or it has to manage the required one. What is the required one here? Required solutions. So we can say that a true maintenance system job is to do the bookkeeping in the sense storing of the knowledge, or we can say the management of the knowledge which is required to provide a solution to the problem. Okay, to provide the solution to the problem, and at the same time, it has to allow to update the existing knowledge base. Because just now we have seen one particular problem. What is that? How to add new knowledge to the knowledge base when the problem solving is in progress. So in that particular case, the true maintenance system should support in updating the knowledge base incrementally, even in the when the problem is in the solving state. So it does not mean that the knowledge base need to be kept ready before starting the solving of the problem. In non-monotonic reasoning systems, what happens? You can infer the new statements, or you can infer the new information even at the time of problem solving also. So who is going to support in updating that knowledge base? The true maintenance system. So by implementing these two subunits in the reasoning systems, we can say somewhat we are going to solve the problems of this implementation. So we need to address, still we need to address some of the things. What is that? The logical issues, talking about the heuristics, and also the design of the problem solver. At the same time, we need to describe the techniques for tracking non-monotonic inferences. Okay. We need to keep track of non-monotonic inferences. Why? Because we need to handle the changes that we are doing regularly to the knowledge base. And we need to see, we need to see whether the changes are doing perfectly or not. Because if the changes are not updating, if the changes are not up to the mark, then again we will fail in deriving the new conclusions. So we can say that these techniques, we can say that they have been divided into two classes. One class we can say it as a depth first search technique, and another one is a breadth first search technique. Okay, so what happens in this particular case means, in depth first search, generally we know, why? Because even in the data structures also, we have come to know that if we are implementing any depth first search, we are going to select one particular path and we will keep on moving in that particular path only until and unless we found the solution. If the solution is not found and we came to the dead end, then we will apply the backtracking and we will try to search in the other branch of the tree. So this is a general thing that happens in the depth first search. In the similar fashion, in order to address the technique, if you are selecting is a depth first search technique, then we need to follow a single path until a new piece of information comes into force, or until new piece of information is available to us. Okay, so if that new information is not available, means if it does not allow us to derive the new conclusions, then what we need to do is we need to take up the other path. But whereas in depth first search, it will not be like that. So it is going to consider all the possibilities. Okay, so if it is a tree-like representation, if the tree is having 3 branches, then every time it is going to consider all the 3 branches. Means all the possibilities that can allow us to derive the new conclusions. Those possibilities that is going to consider. Okay, so we can say that in some cases depth first search is the best suitable technique, and in other cases breadth first search is the most suitable. But for sometimes what happens, we need to understand a particular problem both in terms of the depth first search and also the breadth first search. Means we need to understand what happens, means how we can derive the new conclusions when we are adding this when we are using this depth first search, and at the same time we need to understand how we are going to derive the new conclusions when we are making use of this breadth first search technique. So we will try to understand by taking this one particular example. So in this particular breadth first search, what happens? We need to consider them as a group. So what we do is we will try to eliminate some of them. Why? Because if they are not helpful in deriving the new conclusions, are not helpful in deriving the inferences, then we feel that knowledge is not suitable for us. So in that particular case, what we do is we will try to eliminate them and we will add the new facts to the existing knowledge base. Okay, so eventually we can say that it may happen only one turn out to be consistent with everything we come to know. So what happens? We will come to a consistency state, we can say. So let us try to take one example and we will try to understand how this problem, how this depth first search technique and breadth first search technique are helping us in solving this uncertainty problems. So coming to the augmenting a problem solver. So what happens? A variety of logical formalisms were described so far. So there are a lot of logical frameworks are there. So we need to understand which framework is the best suitable one for us. So they are going to describe the theorems that can be derived from a set of axioms. This already we have seen in the earlier sessions. And even we can say that it is a known fact that problem solving can be done using either the forward reasoning or by using the backward reasoning approach. So we need to understand, in this particular case, we need to understand what is the difference between solving a particular problem in the forward direction and in the backward direction. So if I say that it is a process of making use of these forward reasoning systems, then generally we start at the initial state and we will try to move towards the goal state. So in that will be called as here the forward chaining or the forward reasoning. But when it comes to the backward reasoning, we start from the goal state. We start from the goal state and we will keep on applying the operators or appropriate rules to the situations, and we will try to come to the initial state. But only the problem is, only the difference between this forward reasoning and backward reasoning is, when you are making use of this forward reasoning, you are going to have only one goal. But when it comes to the backward reasoning, the entire process you are going to divide it into several sub-goals. So what happens in the backward reasoning, you have to keep on solving the sub-goals and you need to come to the initial state. Okay. So in the problem solving using uncertain mechanism, uncertain knowledge is having no exception. Okay, there is no exception. Definitely we need to make use of this uncertain knowledge and we need to prove something. So there are two basic approaches we can follow. So there are two basic approaches to follow these kinds of problems, and sometimes we can combine the both also. Means we can make use of the forward reasoning approach individually or the backward reasoning approach individually, but sometimes what happens, you can make use of both also. Means at the same time you will implement the forward reasoning, and at the same time you will implement the backward reasoning also. But only the thing is, when you are implementing the forward reasoning, then it means that we are moving with this particular point, what is known to us. What is known to us. But when it comes to the backward reasoning, we need to determine whether some expression P is true or not. That's why I am saying that whenever you are using backward reasoning, you are going to have multiple sub-goals. You are going to have multiple sub-goals. So in this particular case, what we need to do is, we need to allow the default clauses in the backward rules. We need to support a kind of debate, we can say. So what is the debate? Debate is going to have two things. Means the things are the knowledge which talks about the support and which talks about oppose. Okay, supporting and opposing. Opposing. So in this case, we can say in simple words, not supporting. Okay, we say it is non-supporting. Non-supporting, why, what it is, this means we are going to generate the new knowledge, or we are going to extract, or we are going to collect the new knowledge, and that knowledge includes both supporting statements as well as the non-supporting statements. Okay, that's why we are saying that with this knowledge base is going to have the knowledge which support and at the same time which will oppose. Okay, so opposing of what? Opposing a particular conclusion. Sometimes, for example, P, it is supporting P and also at the same time opposing P. So we need to consider both the things, both the knowledge. So in the backward reasoning, it is going to happen like that. So let us try to understand. This is an example taken from our prescribed textbook. So we will try to understand this. So by seeing this, you need to remember the story which we have discussed in the earlier sessions, that is called as ABC murder story. ABC murder story. So what this ABC murder story is telling, that there is a murder happened. So for that, in that particular murder, three people are suspects. So who is that? One is Abad, Babbitt and Cabot. So these are the three people who are the suspects of the case. So what we have to do is, by using here, it is called as the uncertainty problem. Why? Because we don't have the perfect information to prove whether A or B or C is the culprits. So in this case, what we are doing, we are making use of this non-monotonic reasoning systems, and we will try to understand how we are going to solve it. Okay, first we are working with the backward roots, and by using this specific keyword which is called as unless. Try to understand, while writing this unless keyword, you need to write it in the capital letters itself. Now try to understand. So the story is ABC. In the ABC murder story, first we are three people are involved, and we need to prove whether these three people are the beneficiaries in the sense they are not the culprits, or we need to prove that either of these people have committed the crime. So in this particular case, if you are using the backward reasoning and making use of this unless keyword, how we are going to derive the conclusions? Okay, how we are going to extract the new knowledge? We will try to understand. So first we will come with this particular point. What is that? Beneficiary of X. So this thing, either X here, in this case, X can be either A or B or C. So you can understand in two different ways. One is you can consider this X either A or B or C. Otherwise, you can consider only X as abad for the first time. But in this case, I am trying to explain you that beneficiary of X means X can be beneficiary. Okay, so X can be beneficiary. When the X can be beneficiary, unless he is having the alibi in the sense some kind of evidence. So if that X is beneficiary, when can we say that this X is beneficiary? Means when he is having some kind of evidence. Unless he is having the evidence, we cannot say that he is the beneficiary. So what happens? We say that at that time he is the suspect. At the same time, B can be proved to be the beneficiary when, until and unless he is having some kind of evidences. If such kind of evidences is not there, we consider that B is the suspect. In the similar way, we need to understand for C also. Okay, so we can say that this is the general statement. This is the general statements. So you try to understand. Come to here. So we will try to talk about a particular one thing, that it is about Babat. Okay, it is about Babat. So what the Babat is saying, somewhere else. What does it mean? Means at the time of murder, Abbott was not in that particular place, but he is at somewhere else. He is somewhere else. So how can it be true? Means when it implies to alibi of X. That means X is having some kind of evidence. So here, who is the X here? Abbott is the X. Means whenever the Abbott is having some kind of evidence which can prove that he is somewhere else but not at the place of the crime, then we can prove that alibi is Abbott is the beneficiary. So what kind of evidence it is? Means about the registered hotel. So according to the story, Abbott will tell that during the time of crime, I was in a hotel where the Abbott's name is registered in the records of the hotel. So what kind of alibi the Abbott is giving means the registered hotel. So X is nothing but here Abbott, and Y is nothing but the hotel. So what the Abbott is telling that he is registered in a particular hotel, and at the same time that hotel is not, it is far away from the place where the crime has committed. Okay, so whenever these two things are there, it will implies that he is somewhere else. He is not at the crime spot. But what happens again? Unless will come into picture. That's why we are saying that if we will fail in deriving the conclusions. The conclusions are going to be incomplete. Why? Because you see, up to this particular point, means if you are considering only this particular point, we can say that X is a beneficiary. But what happened? Again, we are making use of the keyword unless, and we are trying to extract the new knowledge. What is that? Unless. So when can the X can be somewhere else, and based upon the evidences he is having, how can we say that X is a beneficiary? Means unless means the registered hotel is the perfect one. For example, if the register is forged, means in the hotel, whatever the register is there, if that register is forged, then what happens? Again, he will become the suspect. So we are going to consider the two things. Means what happens if this particular thing is happening, and what happens if this is not happening. Now coming to the other person. So we can say up to this it is about the Abad. Come to the Babat. So Babat is also going to defend. What he is going to defend? He is going to say that at the time of murder, he was somewhere else. He was somewhere else. So somewhere else in the sense here, he is with his brother-in-law. The story is telling that at the time of crime, so X means in the case, the Babit is not at the place of crime, but he is with his brother-in-law in some other location. So when can this particular B can defend? Means whenever he is having the evidence. Whenever he is having the evidence. But what happens if that brother-in-law is telling the lie? Okay, means X is going to be beneficiary here. X in the sense here, Babit. Babit is going to be the beneficiary here until and unless he is having some sort of evidences saying that he is with his brother-in-law in some other location. But in any of the case, if the Y means the brother-in-law is telling any kind of lie, then definitely again he is going to become the suspect. Okay, so this is all about the Babit. Now let us come to talk about the Kabat also. So again, the problem with the Kabat is what he is saying at the time of crime, he is in some other location watching some kind of game. Okay, so and he is also saying that the video has been recorded. That will be the one of the alibi. So in this case, what happened? Picture of who? Picture of X. In this particular case, X is C. So the picture of C in one particular location, which is far away, which is not near to the crime location, which is far away, then we can which is going to imply that it is somewhere else. It is somewhere else. But what happens there? Again, there are going to be some contradiction. So some contradiction function we are going to make use here. So what is contradiction will have? It is going to be true. It is going to implies to the contradiction when unless some of one is the suspect. Unless someone is the suspect. So in this particular case, what happens? We include this Abad, Babit and Kabat are the beneficiaries. Okay, so in this case, what happened? We are going to include both the things. Both the things means which is supporting to ABC and also which may not support to ABC. So like this, we need to follow in order to solve this kind of ABC murder story problems by using this unless keyword. So this approach is, we can call it as a backward rule approach, where we are going to have the separate subgoals. Why it is separate subgoals means we are considering individually about Babit, Abad, Babit and Kabat. But when it comes to the forward reasoning, it will not be like that. So we are going to represent the entire knowledge in just like a conditional one. So how beneficiary of X. So if X is going to be beneficiary, when he is going to beneficiary means whenever he is having certain kind of evidence. If such kind of evidence is not there, then we can say that he is a suspect. At the same time, if somewhere else, at the time of crime, if X is somewhere else and he is having that kind of evidence, then we can say that again he is also the beneficiary. If the registered hotel, the same example, if the registered hotel is far away from the location, then he can be the beneficiary. But what happens? That need to be somewhere else. It is not near to it. But if it is a forged register, again he is going to become the suspect. At the same time, about these things also. I mean, the same way we need to understand these particular things. Okay, so this is the way how we need to understand how this forward reasoning and backward reasoning is going to solve the problem of uncertainties by making use of these unless keywords. Okay. Hope you understood these two examples, and these are the references what we have used in order to prepare this particular content, and also the examples I have taken from this specific textbook, and you can refer it for further information. So thank you very much, and hope you understood the implementation issues in the non-monotonic reasoning systems and logical systems, and we will try to come up with the other topic in the next section. Thank you.
Like, share and subscribe. hit the bell icon for more updates.